There's an old aphorism that says an airplane is millions of parts flying together in close proximity. At One Aviation, their business depends on each of those parts living up to its individual mission. So the technical review team spends lots of time discussing ways to make each part better, lighter, and more durable. Today, they're discussing the bell crank.
So it should be pretty quick to do the analysis.
Okay, wonderful.
The bell crank. It's one of the many parts needed to keep One Aviation's planes and its business flying. That makes it a great entry into the digital thread. But first, just what is a bell crank?
There's the bell crank up in there.
So I got one here,
Yep.
and I got one here.
So what you'll see is there's a push rod that's attached to either end of this bell crank that's pivoting about.
Okay.
And what it's doing is driving a double action of the door so that when the gear starts to move, the doors open.
Yeah.
And as the gear clears the doors themselves, the doors will start to sweep closed again.
Okay.
Now that we know what a bell crank is, how do you design one? Or anything for that matter? Well, let's start with how we used to do it.
So when I jumped in, we were kind of in a transition phase between working in a more paper-based or on the board and moving into the digital era.
Okay.
So literally you guys were drawing this stuff.
Right. Mylar, prints, ink, French curves. We were kind of at the tail end of slide rules, storing them in a drafting room, a check-in, check-out system that was very manual. It wasn't configuration control in the way we think of today.
Yep.
So a lot's changed in the last 20 years. The visibility that you get, we referred to a drafting room earlier on. There may be only one copy of that print. Now, in the digital age, with PDMs, with a data manager that we can have multiple people reviewing the same thing all at the same time.
So the system's got a control of it. The PLM, this digital thread is going to have control over configuration management so that no one gets the wrong print.
Right.
So it's not just about getting a design out the door quicker. It's about evolving that design over time in a way that lets you constantly deliver an improving product to the market.
Yeah, we're all about customer experience. So we want to make sure that whatever we offer to the customer is of the best experience that we can possibly offer.
As you can hear, designing a part in the digital thread is not just about the software or even the engineers. It's about the seamless flow of information and the right information at that. What's even more interesting is that the digital thread is non-linear. Even though I'm here in the front of our little demo, I could easily be in the middle or even the very end of a design cycle. To learn more about how a part enters the digital thread, I met up with Barry Chapman in his hometown of Chicago, Illinois. Barry is the Vice President of Aerospace and Defense for Federal and Marine Industries at Siemens PLM Software, and he has an informed perspective on this topic. Barry, I want to understand, we talk about this notion of the digital thread, end-to-end, cradle to grave. How does a part actually get into the digital thread? Like, how do we start?
The first way to start from just the beginning is you design the part, right?
Okay.
You design the part in a
CAD
CAD system, you're right. But now you can scan parts,
Okay.
right? So you could digitally scan a part that's existing.
I'm going to get the external dimension of this thing and I'm going to bring it in, and I'm still going to be able to manipulate it in this digital world to either clean it up or get what I need out.
Right, and that's what's different now than in the past, right? In the past, you just take a picture and you call it a dumb part.
Yeah.
Well, now it's no longer dumb, now it's a smart part. You could actually take it, you can manipulate it, you could change dimensions on it, you could change the curvature of the part. You could actually manipulate the part and create something new on it or modify the existing. That's what's unique now.
So scanning is one way, but I also want to learn how to design a bell crank from scratch. In this case, the digital thread really shines. Here we can draw on the data and design requirements for this and other products from across One Aviation's portfolio.
Okay, so on the left, we have our product data manager, which currently at our company's Team Center.
Okay.
And on the right, we have NX, which is our design software.
Okay.
And what's on the screen specifically here is a digital twin or an electronic copy of what I'm holding in my hand.
Okay.
We're still in 3D space.
Okay.
But on this file, if I actually switch to drafting for this file, now I have...
This is your drawing space.
This is our drawing space. Now, 10 years ago, or in the past, what happens is this actually comes before this. Every file inside NX has a modeling space, which is three-dimensional environment. And then it has the flip side, which is the two-dimensional environment.
Okay.
So the design process actually happens entirely in the digital world. And then we move to the point of cutting chips.
Meaning fabricating the product.
Yes. When you set up a drawing, you're telling a story to somebody. And that story has to be in the context of the audience. So the audience here is going to be a whole bunch of different folks. all the way from the manufacturer, the supply chain, the people who have to buy it, to the people who have to inspect it to make sure that it conforms.
Can you draw something simple for me?
So let me start with a blank page here. What you're going to see is, as I draw this part, the real part is going to start really popping out to you.
So those, I'm going to guess those are holes that you just drew that are going to be in this ultimate part.
As a matter of fact, are the corners of the part.
Oh,
So
okay.
if you can imagine, what I'm drawing is this, the outside shape, and this outside
perfect.
shape.
Okay.
So now what I have is a sketch that I've extruded in 3D space. So now I have a solid.
So now I've actually gone from 2 dimensions to 3 dimensions.
Absolutely.
Perfect.
Yeah. I've taken a 2-dimensional sketch and turned it into a 3-dimensional object.
Okay.
In 3D space.
How is it that I can use tools like this to think about achieving the goal of lightweighting this part?
That really is dependent on the level of analysis that you're willing to throw at it.
Okay.
Right now, we are looking toward where the topology optimization would be something that just becomes ingrained in our normal process.
Okay. So I think what I take away from that is we got to go learn something about topology optimization.
Absolutely.
Coming up, we'll learn how topology optimization can help One Aviation create the next generation of lighter, better bell cranks.